Hi, in this video I'm going to cover how to programmatically create TrustStore and KeyStore. Now let's start by understanding the difference between keytool, TrustStore, and KeyStore. So keytool is just an executable that we use to generate stores for storing certificates. We also use it for importing certificates into different stores. Now, the certificates that we import into the store are basically of two types: the root certs, intermediate certs, and sometimes the website certs. The other one is the client certs, which are provided by the API owner to the user. These are basically private keys or identity certificates. The user or client then uses them to identify itself to connect to the security API. The first type of certs, the ICA and RCA, are basically the certs that we trust, meaning we know that the URL is safe to connect to, and the ICA and RCA are not part of the JRE lib security CA certs, due to which we are getting the PKIX exception. So we add them. Hence, these type of certs go to TrustStore. And the client certs are like keys, which help us to access a secured API. Hence, these go into KeyStore. If all of this looks a lot of work, you can always import them in one store and point the system properties to the same store, and everything will work. But if we were to do it correctly with separation of concerns in mind, then this approach will apply. You can also store the certs into CA certs. But the problem is every time your JDK or JRE will be upgraded, you will have to redo the exercise. The other way is to add them into JRE lib security JSSECA certs, and I have a video on that. As long as the JSSECA certs password is changed, you can use that as well. But in this video, I'm going to cover how to create TrustStore and KeyStore using code. We will create them in a temp folder, and every time the program runs, we'll create them, add the certs, make an API call, and then delete them. This way, you don't have to worry about stores. You just need the certs to be in a location that you choose, and the code will do the rest of the work. So if we look at it, TrustStore will contain the root cert, intermediate cert, which will help us resolve the PKIX exception, and the KeyStore will have the cert and key pair, which could be in a PEM format or a P12 format, which help us connect to a secured endpoint and uh, will help us resolve SSL handshake exception. I'll add this link if you want to read Oracle docs. Now, moving forward, yeah, if you like my explanation and videos, please do like and subscribe. So what I've done is I've created the template already, and we will do the exercise of downloading certs and adding them to the code together. I'll paste this URL in the description as well. So if we go to this URL, this is the code, and the README has way to download the certificates from. So you can either fork it or clone it through here, or just download it as a zip file and then import the project. So now once you have the code and you have imported it in InteliJ or the IDE of your choice, it will look like this. It will have a bad SSL folder. This is where we'll put the certificates. It has source main Java or example app. This will basically use to make HTTP calls to an URL, which will connect and print the status code and body for debugging and return the response code. Then we'll have KeyStore handler and TrustStore handler, and we will have test cases. Right now, you will notice that all of the tests will have @ignore, and it is using JUnit 4.12. We do use BouncyCastle, but it's for a specific scenario that I will cover. Now, it's basically if I go to the top and I run it, you will see none of them will run, and that's because we still have to do the setup of importing certs. Otherwise, these will just fail. So now let's start with the preparation. So let's go to this URL, and you see we get this error. So currently our bad SSL folder is empty. So let's download this cert. Export, and the first test case expects the file to be called self-signed, so we'll call that. You can rename it, that's fine, but then remember to rename the file in test case as well. I downloaded the file in downloads. You can download it directly to the bad SSL folder. Otherwise, you can manually copy it like I'm doing now. I'm not going to add it as part of the project Git. So let's start by first reproducing the issue. We will connect to self-signed URL. Let's comment out ignore, and we'll run this. Okay. So we get PKIX. We are using JDK18. We still get PKIX because the cert is not part of the trusted cert chain in JRE security CS certs. That's fine. So what we will do now is we will start with the TrustStore handler class. Now this class basically requires the temporary TrustStore path, the store password, and the type PKCS or JKS. It will first create a store in memory, add the certs that we pass. The certs that we will pass should be of type binary or DER format. In case you have a PEM file, then you'll just have to convert it into DER by removing the first and the last line of begin certificate and doing a base 64 decode. I will cover it as part of Client Cert scenario, and this code simply reads the cert that you pass, one or many, and then it will create a cert entry in the temporary store, and then finally write the store to the location that we provided. So that's all this class will do. Now we want to use this cert for connecting to this URL. So we'll say new trusted store handler. We are saying that the trust store should be created in the temp directory. You can change this. And I've also said that once the test run completes, the file should be deleted. This is to make sure that each test run gets its own fresh file. So I'll say I want to use the TrustStore path, the TrustStore password, and the store type, which I've defined here. You can change this to JKS as well. Okay. And we want to create the store with the certificate, which is embed ssl/self-signed cert. Just copy it here, paste. Now let's run this. This will fail because see, even though I'm creating a store and adding the file, which is says adding the cert to test TrustStore, I haven't set it in path. So it's still using lib.security CS certs. So let's just copy these three and paste it here. Now when it runs, the test passes and we have the site data and the code 200, and that's what we are asserting, that we should get HTTP OK, which is code 200. Now let's move on to the actual scenario where we have the root intermediate cert along with client cert. So if you go to README of the project, so this was the first URL that we connected, and this is the second one, and we can open this. So you can copy paste. What we will do is we will download this is the root cert and this is the intermediate cert. We don't need the site cert because it is signed by the certs, so site cert is not required. We'll remove spaces. Okay. Now these are all in downloads. So I'm going to copy these two, paste here. The third one is already there. So now let's look at this one, and I'm going to comment this. Okay, let's comment ignore so that it runs. I'll get a bad request issue basically. And this is because this website, the intermediate and root cert are already part of JDK18 JRE security CSRs. That's why it is giving us 400 and not PKIX exception first. But if I set the store to this one, now what will happen is it will read this store, and this store only has self-signed cert. So we should get PKIX because now it's reading this store only and it's looking for the certs. So what we will do here is we will append bad SSL slash and R3, so bad SSL slash R3.cert. So now when I run this, PKIX will be gone. We added 3 certs and we got a 400 because we still haven't added the client cert. Now for working with client certs, we will start with the KeyStore handler. The inputs are same, the path of KeyStore, password, and the instance. The first thing that we are going to do with this is to add a P12 to the store. And now because the P12 is a store in itself, it could contain multiple entries, and we are only interested in the entry of type key. That's why we load the key store, we read the password, and then we import the key entry only. So this key entry will be the cert key pair that we are interested in. Because see, the certificates entries we are already managing ourselves and storing them in the TrustStore. Over here, we'll basically say the key store path, password, store type, and we are dealing with P12. So now for this, we first have to download the P12. So if we go back to README, you will see there is this download. So if I go to badssl.com/download, is the option to download the P12 and the PEM. So just click and it should start downloading. Copy, paste it here. So the P12 now, see over here, it requires the P12 file path and the password. Password is this, it's mentioned here, badssl.com. Say badssl slash, if I do shift F6 to rename, I can just copy it and press escape because there's no need to rename this. Say to char array. We have to set up the KeyStore and the TrustStore, and for that I created this method which is setting the TrustStore and KeyStore. You just have to pass the store type. So even though the store type is defined globally, I set this in case you want to try different combinations, JKS, PKCS12, but for specific test case. If I run this, it has the certs, and now it imported the P12 into the temporary store and executed it. To see that this actually does what I'm saying, we can add thread.sleep 10 seconds, open temp directory and run it. So you will see it created test KeyStore and TrustStore. And as soon as it completes, after is called, which deletes them. So they're gone now. So now we have covered the addition of unsigned certificate and testing it, and then the root and intermediate certificate and then testing it. And we have also done the addition of P12 and testing it. Now, let's say you get cert and a key pair. So there are different ways you can deal with this scenario. Now, the first three scenarios, we can use Java without adding any additional dependency. The last two, for those two, we will need a dependency called BouncyCastle. I'll show you why. We'll start getting weird version errors. We will start with, let's say you get a cert and key. So you remember this PEM file that we downloaded. The first half is begin certificate and then it's begin encrypted private key. So let's extract the certificate and key from here to create a scenario where you got the two files separately. And we will work on the first option, DER with unencrypted key. Let's take the cert from begin certificate and end certificate and we will call it cert.pem. The reason the file type is PEM is because, as you can see, this is base64 encoded data. If it was binary data, I'll show you how it looks like now. Then we can call it like CRT or CER. Now let's get the key, begin to end. Call it just client.key. It's fine. Now, this is the base key format that we will start with, and we'll convert it into different formats. The first one that we are trying to solve is for DER with unencrypted key. So we'll take client key and we will convert it, we'll call it PKCS8 DER key. So now if you're using Windows, you will need WinPTY, otherwise git bash gets stuck. It's unable to take input. So now I will load git bash, cd idea project, create TrustStore KeyStore, and embed SSL folder. Now I'll paste this command. Password is bad.ssl.com. This password, we got it from here, bad.ssl.com. Okay. So now we have the key. So now we'll move on to the third test case, right? And we will look at, see, the TrustStore stays the same. We are adding the same three certs. We actually don't even need this one. We only need these two because this one is not used by this URL. We go to the KeyStore handler. Now we will study the add cert and unencrypted DER key. So now if you look at this, right, DER key, I'll open it as text. This is what I meant when I said DER is binary format, whereas PEM is like base64 encoded format. And we'll work on this. Okay, so now we'll have a look at this method. The test is still ignored, it's fine. So we are passing it the certificate and the key. So it will read the certificate and then the key should be of type PKCS8. And that's why if you look at this conversion command that we did, we are saying to use PKCS8. And once we have the key, we will convert it of type private key. And then we set the cert entry as cert alias because in this case I know there's only one cert in KeyStore, so I can call the alias cert, give it the key and then the KeyStore password, and then the certificate goes in the certificate chain. So it basically creates the key and the cert entry under alias cert in the temporary KeyStore that we are trying to create. So now if I comment this, run just this test, so I'm giving it the cert PEM and then the DER key. See, the test case works fine. Now, some devs do not like working with DER, and that's why the key will be PEM, which basically looks like this, but this is of a certain type, so we'll make sure that we convert it into the type that we want. we will copy this. We'll take the original key. We are removing the encryption by saying do not encrypt it, or drop the password. It's still using PKCS8. And if you want to study more about this, right, there's this link which will show you different types and what it means. So now we are working with the PEM format. So if I paste this here, the out form changes to PEM, right? Password is bad, ssl.com. It's the same code. So if you look at the test case, right? So now we are moving to this one where it is unencrypted but PEM key. The problem here is that the code, Java code, still expects it to be in binary format or DER format. Now, if you look at the PEM key, it has this line begin private key and this line end private key, and then this is base 64 encoded data. So what we'll have to do is we will skip these two lines and convert this or base 64, decode it, and then use it, because then it's basically DER format. So if you look at this method, add cert and unencrypted PEM key, all we are doing is we are doing PEM to dir first, and it's exactly what I explained. You read all the lines and then you remove the top line and the last line, which is to skip that and that. Then what you do is you base 64 decode and then you pass it to the same spec. Then the code is same afterwards. And again, because after each test case, the files are deleted, so I can use the same alias cert. Now, if we go to the test, we comment this so that it runs, and then we run it, and you'll see this works. Now, it is normally not considered a good approach to leave the keys unencrypted. So we'll use our key, convert it to type 3DES, keep it in PEM format. So we will convert it from PEM to DER encode, then connect to the URL. So 3DES is still better than DES, but not as strong as AES. And you can go to this link and read the options here to see what I mean. It will explain the V1 format and the V2 format and how do you deal with each one. So we will open README, copy this command, paste bad ssl.com. So this is the current key password. And now it wants us to set the password for 3DES key that we are exporting, bad ssl.com. So we have that key now. So if we look at this one, which is 3DES encrypted key, it's the same structure. It's just that because now the key is password protected, so we pass in the password and then we read the key. We converted it to DER because this will be of type M. The algorithm that we use to encrypt the key, we need to get it from the SSL key factory and then apply it to decrypt it. And then once we get the key after decrypting it, we can use it or set it. So if I run this one now, see it says SHA-1 and DESEDE, and it basically asks the SSL key factory to get that and then use that. Now, so if we go back and then copy this, we'll convert the key to AES, bad ssl.com. ssl.com, bad ssl.com. I'm basically keeping the old key and the new key password same. So now we have the AES one. Let's do this. See over here, I'm using BouncyCastle, right? So instead of calling BouncyCastle, let's call the 3DES one. So when I run this, you see in JDK18, it is saying PBES2 secret key factory not available. Now, if I change this to use JDK11, okay, and rerun it, it will say a number and says this no such algorithm exception. So this is where developers will waste a lot of time, and that is where you will need this dependency. This library can actually handle the AES types. So if I go back to my test, do this, and now it's basically using BouncyCastle provider. See the certificate I'm still reading using the as is structure. It's just that the key I'm using the BouncyCastle provider to handle that for me. Over here, this read object is important because basically what is happening is you give it a key, it gets, this is the PEM parser, it basically parses PEM files. Now in this PEM file, there is only one entry. That's why we are simply saying read object. There's only one entry, you read it. We know it is of type private key info because we know it's private key. Once you have done reading, then you find the decryptor and then you get the private key. Now this private key line is basically the same that you see here because BouncyCastle has done the decryption part. So now if I run it, it will work. So let's go back to the last operation where, see, BouncyCastle can read the cert file and it can also read the key file. If you get a PEM file with a cert and key entry, and you can look at it, it could be like, it could have multiple cert entries, which are your root cert, intermediate cert, and then the site cert along with the key. So have a look at the contents of the file before you write code, which brings us to the last bit where we will use the PEM file, add certain key from PEM file, right? But we will use BouncyCastle to do everything. So we'll start with the provider as BouncyCastle and then set the PEM parser. So now here we know that the first entry is of certificate, and that's why I'm saying when the PEM parser reads the first object, so basically what it does, it will sort of ignore all this and just read content and convert it of type certificate X509 certificate. So I know that's the first line, that's why I'm doing this, and I know the next line is of type key, so that's why I did this. But you can also add instance of. So let's say if you have multiple entries, then you can use the read object instance of X509, then do this. If it is instance of that, then do that. You can write your code accordingly. And then you just add the key and the certificate that you read in key entry. So let's say if you had root, intermediate, and certificate, you can then basically loop through this section, or you can create an array of certificates and then you put that here. Right now there's only one certificate, so I'm just setting it here like this. And then you store the KeyStore. Now if we run this, you can see this is reading the PEM directly with the password. You'll see that it works. Hope this helped. Thank you for watching.